Hey everyone, and welcome. Today we're tackling a Leetcode problem called divide array into arrays with max difference. The goal is to split a list of numbers into small groups of 3, but with a specific rule about how different the numbers in each group can be. Don't worry, we'll break it down step by step. So here's the official problem. We're given a list of numbers, called nums, and a single positive integer, kfebs. Our job is to divide the entire list into smaller arrays, where each one has exactly 3 elements. The main rule is this: inside any of these small 3-element arrays, the difference between the biggest and smallest number must be less than or equal to k. If we can successfully divide the whole array this way, we return a list of all our small arrays, but if it's impossible, we just return an empty list. Let's look at this first example. We have a jumbled list of numbers, and our k value is 2. The problem is, how do we even begin to form these groups? The numbers are all over the place. Somehow we need to find a way to group them. A valid solution, as you can see on the slide, would be grouping the 2 1s with a 3, then another 3 with a 4 and 5, and finally the 7, 8, and 9 together. If we check each group, the difference between the max and min is always 2, which is exactly our k value. Since this works for all groups, this is a valid answer. The big question is, how could we discover this grouping ourselves? Now let's look at a case where it's impossible. Here our k is still 2. We have 4 2s, a 4, and a 5. No matter how we try to group these numbers, we always end up with a group that includes the number 5. And in any group that contains both a 2 and a 5, the difference between them is 3. Since 3 is greater than our k of 2, that group is invalid. Because we can't find a single valid way to partition the whole array, the answer must be an empty list. Thinking about all the possible combinations is really complicated. But what if we could simplify the problem? Here's the big aha moment. Inside any group of 3, say A, B, and C, if we sort them, the largest possible difference will always be between the smallest and the largest element. The difference between B and A, or C and B, will always be smaller. So we only need to check one single condition for each group. Is the largest number minus the smallest number less than or equal to k bins? If it is, the group is valid. This realization makes things much easier, and it suggests a powerful first step. Let's just sort the entire input array from the beginning. By sorting the array first, we can create a really simple and effective algorithm. First, we sort the entire nums array. This puts all the similar numbers close to each other. Then, we can just walk through this sorted array, taking 3 numbers at a time. For each of these little groups, we check our simplified condition. Is the third number minus the first number less than or equal to k? If we find even one group that fails this check, we know it's impossible to continue, so we just return an empty list right away. If a group passes the check, we add it to our answer list and move on to the next 3 numbers. If we make it all the way to the end, we've successfully partitioned the array. Okay, here's the full Python code that implements our algorithm. It might look a little dense at first, but it's actually doing exactly what we just described. Don't worry, we'll walk through it piece by piece on the next slide. Let's break it down. First, the most important step, we sort the list called nums. This puts everything in ascending order. Next, we create an empty list, which we're calling result, to hold our final answer. Then, we start a loop that's set up to jump through the array 3 elements at a time. So I will be 0, then 3, then 6, and so on, marking the start of each new potential group. Inside the loop, for each chunk, we perform our simple check. We take the element at position I plus the largest in our little group, and subtract the element at position I, which is the smallest. If that difference is greater than k, we immediately know a valid partition is impossible, so we return an empty list. If the check passes, it means this group is valid. So we create a new list containing the 3 elements from our current chunk and add it to our result list. And that's it. The loop continues until we've checked every chunk. So how efficient is this solution? The most time-consuming part of our algorithm is the initial sort. Sorting an array of n elements typically takes big O of n log n time. After that, we just loop through the array once, which is much faster. So the overall time complexity is n log n fris. For memory, or space complexity, well, we need space to store the final result, which will have n elements in total. Some sorting algorithms might also use a little extra space. So we can say the space is roughly order n. This is a very efficient approach. So to wrap things up, what's the big lesson here? The key takeaway is that sometimes, sorting your input data can transform a complex problem into a simple one. By sorting the array, We didn't have to worry about all the possible combinations. We could just greedily take the next 3 elements and check a single simple condition: is the difference between the largest and smallest number in that group within our limit, k? This turned a potentially messy problem into a clean, efficient, and easy-to-understand solution. I hope that explanation was clear and helpful. If you found this useful, please hit the like button, subscribe for more Leetcode walkthroughs, and feel free to leave any questions in the comments below. And if you're feeling extra generous, you can always support the channel by buying me a boba. Thanks for watching, and happy coding!